This is an experiment to demonstrate position and speed control of the DC motor. There are two microcontrollers. This is a 16F88 and this is a 16F84. A keyboard is used to input data, and an LCD display displays the data that's input and also provides information as a user interface. The motor, DC motor, is driven by an HCTL bridge, which is interfaced to the microcontrollers. And the motor has an encoder and a planetary drive attached to it. Now, let's talk about why we have two microcontrollers here. The main reason is we have a limited number of output ports on one microcontroller. Therefore, we decided to use two, one of which is the master controller, or the main controller, that controls the DC motor. The second microcontroller, the F84, provides input data from the encoder and then transmits that data to the main microcontroller using a serial interface between the two. This is the LCD user interface that can be used to display the main menu, the position menu, the speed menu, and the menu that allows us to change the gain and the pulse width modulation. Let's begin by looking at option 3. The gain we're going to select is 100 for the proportional gain constant, and the pulse width modulation will be 40 cycles. This is an optimal setting that provides reasonably fast speed and very little overshoot. Now we'll go to position control. So let's begin by selecting 2, which will give us a rotation of 45 degrees of the disc at this point. And by picking 3, we will rotate an additional 45 degrees. Therefore, our termination is 90 degrees. Now let's enter the speed control mode. By depressing the second key, we have the option of changing the speed, that's the rate at which pulses are applied to the motor, and whether the motor rotates in a clockwise or counterclockwise direction. By selecting 1, we will rotate clockwise, and by selecting a speed of about 50, we'll get a nominal speed. We execute by pressing 0, and notice the motor then rotates at a constant velocity based upon our input values, and then we can terminate that rotation with the stop button. So now we'll demonstrate increasing the speed and changing the direction. So in this case we're increasing the speed higher to a higher value, 80, and we'll change the direction to counterclockwise and depress 0 to execute. And notice higher speed rotating in the counterclockwise direction and termination. Now we'll select a slower speed. Let's pick a speed of about 20. And in this case, let's go back to clockwise, which would be 1. We press 0 to start, and notice the slow rotation in the clockwise direction. There are two specialized integrated circuits that are used on this protoboard. The first is a keyboard encoder that allows us to directly input data from the keyboard to the microcontroller. The digital encoder on the motor is coupled to the microcontroller through a quadrature decoder and counter that provides data that can be directly read by the microcontroller.